Hi, everyone. Hi. I am Matteo. Today, I'm here speaking about swimming in the microservices ocean. I work with a company called Nearform. I will tell something later about the company. It's not. You're not here for the company, right? So we are here at Codemotion. Hi, Codemotion. Okay. This talk, we should have been two doing the talk, you see, one and the other one. But the other one is in New York doing a very similar speech at another event, so we couldn't be here together. Hi, Luca, thank you. The title is Lucas, okay? This is Lucas' title. Anyway, this is a long story. It's a long talk. So once upon a time, we all deployed things as a monolith. Okay? It's very nice. Very easy to deploy this. I don't know. Is there anybody that hasn't ever deployed a monolith here? Okay. More or less, what you have done, you had a nice load balancer. If you didn't have a load balancer, sorry. Okay, it's not. The talk is not for you. But you have a load balancer, and you have some code running somewhere on some servers, possibly Linux, but whatever. That provided horizontal scalability. This is the easiest way to run some software. Okay, and you have some bunch of databases, WorkQ, HTTP, API, there's 0MQ, whatever you want, something else. Okay, that this code is calling. So, well, at some point, project grows, success, and my monolith becomes a big ball of mud. More or less, I don't know how many of you have experienced some of those big ball of muds, but whatever. Well, in this big ball of mud, what you add is what I call round-robin load balancer, okay? And you get a user, and every request goes to a different server, because it's a round-robin, okay? And in fact, all the data is fetched all over the place every time. We get the first user, goes to server A, then on another call, the same user, we post it to server C, and then the other one goes to server B, and everything goes into the database. This is how all of our system works, okay? Because all of those servers are all stateless. We write stateless servers, okay? And because they're stateless, we design them as stateless, right? So any local state is, we can get that. We can cache locally because, well, all the servers run all the users. If you have 100,000 users or 1 million users or 60 billion users, whatever, you can't have any local state at all. Yeah, well, that's how we did things. Now, well, for a very long time, this is a nice principle, past a while. And, well, this new idea, microservices, has been there for a bit. And this is how you do things, okay? And more or less, this is how all of us, we are doing things on a bigger scale. This is the big ball of mud, but untangled, okay? It's the same logic, but divided into multiple microservices, okay? And where we got that communicate using different communication patterns, right? Different. And where the servers, and there are some main servers that orchestrate all of them. Wow. Or an API gateway. Do you love API gateways? I don't know. Somebody does, maybe. I don't know. I don't. You still have a load balancer, okay? By the way, if you're still running Apache today, how many of you are still running Apache? Stop now and run Nginx, please. Just saying. Okay. Make the world a greener place, consume less power. So, well, I don't know. Hipsters. It's needed. It's a needed slide. This is from Luca. This is Luca's gift. And this talk needs to be this slide, okay? Because microservices is the new hipster. It's the new thing, okay? Now, if you go back, not a hipster, okay, to this slide, you see that those are still all of those stateless, okay? Most of those services are still stateless, okay? So, in fact, we have a bunch of databases and WorkQ and external services that hold state. So we have still a place where everything is tangled and blah, 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 which is where we store the data. Now, all of these, there is a problem there. The start of our assumption, which is that our services are all stateless. Okay? All of these holds for stateless service. Now, a lot of the things that you use today on your phone, on the web, in fact, are not stateless anymore, are stateful, completely stateful, because there is a live WebSocket connection, because they need to send live updates, because there is some users, some data that belong only to you, for which you need to refresh your page on behalf of the server. Okay, how do you scale those? Well, the problem is that stateless microservices, yes, are resilient, but not. You can't write only stateless microservice. Okay, so well, there is this technique called application level sharding. Okay, and application level sharding is a really nice technique because it allows us to say, well, all the users go, all user 1, 2, 3, 5 is always served from server A. Now, server A is there. Okay, and well, how do you pick those? We'll see it in a minute. But this is nice, okay, because it allows you, well, this is where your data relies, is that server. Or, by the way, this can also be a data center, okay, just in case. I remember the days when Facebook was just born, and I was able to sign up for, well, long story. Nobody was there, more or less, none of my friends. And a lot of people started asking me, well, what is this Facebook thing where you can put weird apps and GIFs on your wall? And because I signed up so early, my profile was sitting in the US data center. And when they started spawn the European data center, my profile was always out of sync because they were doing application level sharding between two different data centers because of the region you were connected from. So people were posting on the groups, and I was never seeing it. It was very frustrating. They solved it very quickly, but anyway, I remember the point. I understood it years later, by the way, because I was too young. So this is how application level sharding works. We have a bunch of users, and the users, depending on their ID or whatever rule you want, they are assigned on different servers. And there is a bunch of routing logic that decides where things relies. The problem with this is, what if the topology changes? How do you change the routing logic? And well, you probably have seen this coming. Service discovery. Okay, this nice little library of servers where we need to find the right place. Ooh. How do you do that? Oh, well, console. How many of you love console, have deployed console, and have fun deploying console? The fun part is important. Did somebody have fun deploying console? We can also use etcd, which is another fun thing to deploy, especially in a Kubernetes fashion, whatever. This is the question, do we really need another piece of infrastructure? I don't know. Can we just detect the failures by heartbeat? Can we just, well, you know, are you alive? Are you alive? There is this other nice tool that you probably don't know about called Surf. And Surf is really nice. It's at the basics of, it's used by console just to do that thing. You can run it on your own. It's really nice. It's a nice piece of software. It's also used by Kong. Well, I don't know. But it's still another piece of infrastructure, you see. It's still another piece of infrastructure running. I don't know. Maybe not. I wrote this thing called Upring. It's a framework. I have a demo. So let's hope that, so I did this demo twice. There's a new demo and an old demo that I did twice. Both of them, the demo god didn't assist me. So please, everybody, hold the finger for me that the demo gods work now. So, okay. So the first one that we are going to run is a little chat room. So this is still a black screen, you see. And we can go here. Now, I have written this thing that allows me to visualize the state of my cluster. So we have 3 peers organized in a ring. We'll see that in a moment why. Now, what I can open is my load balancer running across my 3 peers. And this is the wrong address, you see? Because this is the presentation, while instead, again, I want 8082. This is my little testing. I wrote this little, very simple chat application, okay? So what we can do here is we can, for example, subscribe. And we can subscribe to hello. And as you can see over here, there is a hello appeared that gets route me to this server. This server, yeah, this server here is this one. It's listening on port 3042. Now I can publish things. So I can publish hello and publish word. And, oops, I clicked the wrong one. Yep, hello word, another one, we received the message. Yes, this is right, it's the same host, so I might not even be running this. So let's open another one. And let's publish some things. Hello. Again, I published it, and again, we got it here, third one that happened. I can subscribe to more different things, like, for example, using wildcards, okay? So I subscribe to a wildcard here, and then I can publish something, and this guy will have received my thing, okay? So, well, I have 3 peers. They auto-organize themselves and dispatch the data. Now, the full logic is all those data, independently on which the peer, to which the peer goes, it's always routed to this same server here, okay? This is depicted on this color, which is 3042. So now it's 3042. Now, what I can do is I can go to 3042, which is my server. Okay, this is my server. And this is my server, and I can very nicely just kill it. So I killed the server that was running that connections. So wait a second. This guy has been updated. So my control UI is still there. And these are my subscription to Star is still working. Let's try publishing. Whoop. Of course, the demo gods are with me. This crashed. Come on. Demo gods. Again, I've been hunted. Localhost. Wait a second. This is dead. Wait a second. There is some stuff running on my system that is eating up all my CPU. What is this? It's Google Chrome helper. So I crashed Chrome. This was a nice one. This is a Dima video demo, okay? Okay. Now, maybe this can, yeah. It crashed Chrome, nice. So we can subscribe again, and all of this is still working, okay? And if Chrome didn't have crashed, oh, this is the wrong one, it will still be there. Now, the Chrome crash was a new failure, you see. It's, the demo gods are not with me. It's, so I can, of course, restart this thing, and hopefully my system, oh, channel destroyed, nice. Keep dying, whatever. So, big question mark. So, the next one. I have another little demo to show, and hopefully that one will work. Clear. And the other one, it's a little key value, it's a little key value store. And this little key value store, it's over here. And we can refresh this thing, and yep, I have 3 new peers, and this one can die horribly, so maybe it doesn't crash things. So with this thing, we can actually store data. Okay, so we see the 8082 and /hello. It's a little key value store over a REST API. So we store data, and well, this is 200. Then we can get the data, and whoa, yeah, it's what we wrote. And you can see here it's -hello, and we can see here that we got this nice thing. 3043, which is my my server. Now, this is the moment, Thomas. So I killed my server. And the data is still there. Okay? That one didn't work last time. In fact, these two servers are still there. Okay? And these are the other one. And I can see here /hello where things were, and this is here. So you can even predict where a thing will be. If I restart this guy, okay, what I get, this is get updated, and my data, it's still, where it is, my data, it's still working. Now, there is one more thing that I can do. So I never remember this command, so let's see if it works. Yeah, live true, okay? Yeah, you see, I've started a server-sent event. Now, server-sent events are audible. Don't use them, but they are nice for the demo. It's because I can demo it with curl. So I can start and send a post and update my value. So, for example, word2, and I get the live update, okay? Through all my servers. Let's try and see if this works. I haven't tested this before, so I hope it works. H2, yeah. So it also works through the load balancer, okay? So I can even send an update, and yeah, you see it's keep going, and I can kill the server, and this will keep running. So yeah, what was all of this? Okay, well, I don't know. Chrome is not nice, you see. Chrome is not liking this presentation. Let's go forward. Too many animated GIFs. So this is the slide I wanted to show you. No, it's not. So this is how uplink works. So the request comes into the load balancer, and they go into whatever, a round-robin fashion across all my cluster. It goes into whatever peer, okay? I don't care. Any peer in the cluster. And now there is the key that I'm trying to access, it's get hashed into one single peer, okay? And this data is the server that is the leader of my database. And on write, well, when I write something, I need to copy it on other two peers, so to replicate data. When a peer dies, now there is this one that will take over. Okay? Now, you can now wonder why this is a ring. And it is a ring because the keys are hashed into a key space of 32 bits in this case. Now, it's not a big key space, but who cares? We need a way to compute those hashes really, really fast. So what happens is, well, a key is hashed here, and if we go back here, its key is hashed in so this is a point, and on this specific point here, and this is a arc. So if between this point and this point, it belongs to peer A. Well, all of this I didn't invent all of this. I just wrote the code. This is nice paper called Dynamo from AWS. It's a really, really nice paper if you are into any peer-to-peer system or that distributed database or whatever community on all of that. You should read this. It's a milestone. It's a basics of RIAC, the DynamoDB from AWS, of course. They wrote it. It's used in Redis. It's used everywhere. Okay, it's a technique. The technique depicts exactly the key space as I showed. This is a diagram taken exactly from the paper. And basically, you hash a key, and this is arc. This is point for server A, and it's assigned here. Now, the problem is this guy says, well, there are a bunch of servers that are in a key space. Now, the problem is what happens if the topology change, and why this talk is called Swimming in the Microservices Ocean. Because there is another paper that you should read. It's called Swim. So swimming. But no, you don't laugh, whatever. So Swim is scalable. It's a gossip it's a peer-to-peer discovery protocol that works up to thousands of servers. Weakly consistent in the sense that the actual state of the cluster, who is alive, it converges over time. Okay, there is a delay after server dies, and after which everybody agrees that that server is dead. In function style, it means that I send a message to Thomas, and then Thomas that is dead. So one is dead. I send it to Thomas. Thomas relied to somebody else. So there is this circle. So it's not everybody that talks to everybody, because otherwise, if we did that, that will create a massive overhead for the system. It's also based on UDP, and it is a membership protocol. So we know who is on the cluster. Well, this is the basic idea. Let's organize our piece in a consistent hashing using Zwim to detect failures, to detect the state of the cluster. This is the magic I talked about. Okay? And in fact, again, this is the key point where we have the consistent hashing, as I showed, 0 hash ID A, 0 hash B, you see? Now, this diagram is wrong. Can you spot what mistake I did in this diagram? Equals. There are a lot of bunch of equals missing. Great. How many of you know what Raft and Paxos are? So those are another 2 different papers that you should probably read, which is how database works and how you produce consistency in a database. This is how, for example, your SQL database works. Okay, when you want ACID properties on a database, this is how it works. So in Upring, the leader for a space is statically allocated based on the key. While in any database, that use Raft or Paxos or whatever system that is ACID, there is a single leader that writes things, or multiple, but whatever, that are elected by all the peers. And there are some other difference. So in order for Upring is an eventual consistent system because depends on the gossip network, depends on the swimming, okay? And while in Raft, you will need 5 nodes. This is the thing. You need 5 nodes, otherwise it doesn't really work. When you use a TCD and you want to deploy a Kubi cluster, you have 5 nodes. Hey! Wait a second. Tirpo, come on, make the picture. So this is a nice slide, you see, because I was really bad and I drew it. So these are some nice events. So what it happens is Upring emits some events where you're allowed to add a new peer. This is the state. There is 2 points in the hash in my hashing, and in my key space. And there's a new peer, and then B, and you see that's been still some part of the key space. And now we need to move data from A to B, the responsibility for the data. And the same thing happens when a peer dies and we have a steal event. Well, let's see how this works. So this is a library. It's written in Node.js. So I'm sorry. How many of you don't like Node.js? Perfect. OK, I'm sorry. I can try to convince you later on. OK? I can try to turn you later on. This is Upring. By the way, all of what I showed is not related to Node. I use Node to implement this thing. You need to specify a base peer. Okay? In order to join the cluster, you need to say, well, you need to have somebody else, whatever it is. You can use DNS, whatever you want to detect this, but you need somebody else. You specify a log level. Now, I don't know how many of you follow me on Twitter. I hope so. Follow me on Twitter, @Matteo Collina. And I tweet a lot about a library called Pino. It's my little logger. It's really fast. So this is why there is a log level there. And there is some hashing properties, which is the replica points and the join timeout. The more peer you have, the more you have to wait for the join timeout, more or less. This is the situation. Depends also on your network. If you are on a distributed network, whatever, higher join timeouts. If you are on a very close, tight network, smaller join timeout. And the replica points on the ring, okay? This is if you want more peers, you need more replica points. If you want thousands of peers, you will probably need 100 replica points. If you just need 3, 4, whatever, then it's fine. How do we add path? So Uppring is built on patterns. Okay, you specify a pattern. It's based on concept of pattern matching. So what it happens is that you specify a pattern, you specify a k value, and you say command put. If you see a command put, we do some things here. Okay, and we can send requests in this way. We say that the namespace is k value, and then send a command get and the key. The key is mandatory. It's important. Also, we can do live updates. Because with live updates is the key feature. I build this for live updates, okay? So this is actually needed. What it uses Node.js streams. By the way, so how many of you, so 1/8 Node.js, how many of you use Node.js? Okay, how many of you have used streams in the past? Okay, perfect. Use more streams. I maintain streams for Node Core, so just saying. If your yarn broke some time ago, that was me. Sorry. If you're using yarn and I broke it, yeah. I don't maintain yarn. I just maintain something that yarn uses. You instantiate readable, which is a type of stream, which is a read method where we can use to emit data, and we just put the updates in our response. And the channel for Uppring is fully multiplexed, so we can run multiple streams on top. It's similar to some extent to HTTP2, but we don't have HTTP2 on Node yet, so this is this thing. So very similar thing, we can issue a request, we get our streams back, and we start update. We send updates. There are some more fancy API to track the key on a system, on an hashing. So we can say if we are responsible for a key and the status of my Uppring change, I can get notified. Or if I want to be notified if I become the leader for that specific key. So, how much? I have more 10 more minutes, okay? This was a tough talk. I hope you got something from it. There is some more things. The library that this uses called Tentacoli. It's a request response for Node based on streams. And it's fully multiplex, as I said, and it's really easy. You can work over WebSockets. This is what you see going on the Uppring control dashboard, and what it is. Really simple to use, very similar to what you see in Uppring. Okay, and this is how you handle things. Again, streams, the same thing you saw before. You can even reply with a file. Okay, you can even send a file through. So you want to implement your own type of block storage? You can do that if you want. All of this, the pattern matching logic is done by Bloomrun. This is Bloomrun. It just does the pattern matching thing. By the way, this runs in the browser. So I'm running the code in the example. And yeah, so there is that. So just to recap a little bit. Uppring is a framework to build a little key value store, or a cache, or a PubSub system, or a real-time application. Okay, IoT. I wrote this for the IoT, for example. A discovery system, if you want it, or a metadata for microservices, or just whatever you want, really. Okay, it's a framework to build stateful distributed system. Some links. This is Uppring. Okay. By the way, I designed the logo. So if you have any concern about the logo, tweet about me, and please help me with the graphics. There is Uppring key value. This is what the key value store I showed. Uppring control is my little nice visualization. This is the PubSub. OK, so it's time to finish off. This is me. Hi. What I do, I work with this company called Nearfirm. We are a Node.js consultancy company, actually, a JavaScript consultancy company at this point. So we provide professional services on top of anything JavaScript, so React, Node.js. And I am a member of Node Core, so I am a Node Core collaborator. So again, I can try to turn you. I can make it, I'm sorry. I've done a lot of things in the Internet of Things, so you probably, if you have played with an Intel Edison or Node.js with the IoT, I wrote MQTT.js, which is a nice library for MQTT. for Node and the browser, really used by everybody at this point. I wrote Mosca. I wrote Pino, my fantastic logger. So use it. And I have to say, I'm really sorry that as much as I want, because up till a month ago, I was at 3,000 contribution per year. Thank you, folks. And if you have any more questions, I'm really open. If not, whatever. And I have a little demo for you to run here. So you can see my nice demo. It's coming. This is a nice demo. Tweet about me. So do you have any questions? Dad. So if you don't have any question about after this presentation, maybe my message was not really clear. I'm sorry. Oh, you're watching it. Ok. Whatever. Ci sono domande? Niente. In italiano magari, così. No.